Welcome to Olympian Water Testing, giving you the best in water analysis. Today we're looking at Springer Link Water Quality Risk Assessment of Copper Content in Drinking Water and Stored in Copper Containers. So we're taking a look at how this is a risk, if it's good, if it's bad, what happens with it. So in most developing countries, drinking water is still a serious challenge. Many water purification methods exist, but they're costly and out of reach for many people. Copper is an ancient metal that has been used for several thousands of years. Because of its antibacterial properties, ancient cultures held this metal in high regard. Copper vessels are still in use today for storing drinking water due to its ability to purify water. Therefore, the objective of this study was to evaluate copper concentration in drinking water after storing copper containers and bottles over different time periods. With respect to copper safety levels, for this study, water is stored in a copper container with up to 608 H, and the water samples are collected at different intervals. The concentration of copper is analyzed in water samples using ICP-MS and ranges from 0.009 to 0.82 milligrams per liter, which indicates as time increases simultaneously, copper content also raises in the stored water. The higher the copper content was detected at the sample, 168H, which was also well within the permissible limits of the World Health Organization. So we have the information here about environmental pollution, and then they have their materials and methods. The sampling strategy, that is initial water sample, was connected from the drinking water tap, stored in 100 milliliter capacity copper containers, after methodically rinsed with distilled water Alpha 2012. This water sample was collected from the drinking water tap, which is basically used for drinking water purposes, 8 p.m. CST on December 2020, and found about 120 milliliters of the first sample was taken 12-hour periods from the time frame waters collected in the copper container, and the sample was named 12H. Similarly, the rest of the 5 samples were then taken at time intervals of 24 hours, 48, 72, 96, and 168 hours at 8 a.m. CST on respect. They were named as such. Finally, all the samples were stored at 4 degrees Celsius, and chemical analysis of copper concentrations was performed by using an Allergent 7900 inductively coupled plasma mass spectrometry using the APA method 200.8. In addition, the basic water quality parameters such as pH, electric conductivity, and total dissolved solids was performed for collected water samples from copper container following the standard methods of the American Public Health Association. The pH of the collected water samples was measured by the pH meter, and the pH meter was calibrated with 3 calibrations prior to the measuring of the water samples. The EC samples were measured using an electrical conductivity meter, and the meter was calibrated with the known conductivity 3-point calibration standards. The determination of the TDS in samples was performed according to the standard method, and a fixed volume of water samples was filtered through the TSS fiber filter into a pre-weighed glass beaker. The filtration was heated over 180 Celsius until the water was completely evaporated. The remaining mass of residue represents the amount of TDS in the sample in the picture form. So we can see the time right here with the different samples and the ICP-MS. What were the results? The measured concentrations of the most psychochemical parameters, including pH, EC, and TDS of the water, are in Table 1, which we can see these tables right here. These are the actual results, time in hours, and the concentration of copper right here. You can even see this in this figure as well. But just to break it down, the pH values of the water samples are found to be in the range of 7.20 and 7.16, the mean of 7.07, which indicates all collected water samples are in neutral condition. Moreover, results clearly designate pH of collected water samples are within the accepted limit of 6.5 and 8.5 prescribed for drinking purpose in pH distribution. The measure of concentrated EC from 161 to 188.2 with an average of 182.67. Distribution of EC shown in this figure as well. In all collected water samples, the concentration of TDS 79.1 and 94.5, and its average 90.01 milligrams. It indicates the concentrations of TDS is within the allowable limit of 500 milligrams per liter. So we can see the results of the concentrations in water samples stored in the copper container. So it's taking a look at the risk assessment of copper content what it's showing is how it was calibrated in this experiment. What we can conclude, more than likely, is some copper in the water is not harmful, but there can be an overamount that is. So with this in mind, it shows an interesting example of how copper interacts with water. And a lot of pipes are copper nowadays. So it's always a good idea to test your water for high levels of copper.